Okay, let's do a recap for chemistry because I know our lecture went quickly and some of you have not had chemistry before, so this is all new information to you. First, we talked about a component of an atom. So when we're talking about any one of these elements on the periodic table, we can refer to those as atoms. All atoms are made up of subatomic particles. We talked about the three. We had protons, which are positively charged, neutrons, which are neutral, and electrons, which bear a negative charge. We talked about the differences between them. So protons and neutrons are located in the nucleus, and electrons are out there in an electron cloud or rings. One other difference that's really important when we go to work with finding the number of protons and neutrons based off of the mass number is understanding that protons and neutrons each have a weight that's assigned as 1 AMU or atomic mass unit. And because electrons weigh about 1/2000th of a proton or a neutron, we just assign them 0 AMU. Their weight is negligible to the actual weight of the atom itself. Okay, so let's review what we're seeing when we look at a periodic table. We see the atomic symbol. So for example, carbon right here is represented with an atomic symbol of C. Some other information that you're given is right here. This is the atomic number, so atomic symbol and atomic number. The atomic number is really important, and it's provided to you with the periodic table because this tells you, this is your atomic number, tells you the number of protons is equal to number of protons. If we're working with an atom that is electrically neutral, meaning it does not have any charge, so an example of something that has a charge would be an ion, so a chloride ion or a sodium ion. Those are ions and they have charges. Electrically neutral, something like carbon as it's represented on the periodic table without a charge up here would be electrically neutral. So anytime we have an electrically neutral element such as carbon, the protons or the atomic number, which you can find and reference here. So we know the number of protons is equal to 6. It's electrically neutral. It doesn't have any charge. So therefore, we have to balance that out with the same number of electrons. So anytime we look at any one of these, if we look at beryllium, the number of protons is 4, and so would the number of electrons. If we look at oxygen, it has 8 protons and 8 electrons, as written there. We'll work with charges in a little bit. So we can determine, based off of the periodic table, the number of protons and electrons. The only thing you cannot determine by looking at the periodic table is the number of neutrons. The only way that you can determine the number of neutrons is if you're given something called the mass number. So I'm just going to write an X right here to represent any atom or element. And they're typically written with the mass number as a superscript on the left and the atomic number below it. And remember, up here, the atomic number is equal to the number of protons. So this is equal to number of protons. And the mass number, which is something new, which I haven't talked about yet, is equal to the number of protons and the number of neutrons. So if we're given the mass number, we can figure out the number of neutrons. So let's do an example. If we have oxygen, let me switch over. If we have oxygen, and we are giving a mass number of, let's do 20. How many protons, neutrons, and electrons do we have? So we were only given one number, and that is the mass number. But remember, we can always get the atomic number by looking at the periodic table. So looking at oxygen, we already did this. Our atomic number is 8, so we can go ahead and fill that in there. So atomic number equals the number of protons. So we have 8 protons. It's electrically neutral, meaning that we don't have a charge over here, which means we also have 8 electrons. Now we just have to figure out how many neutrons we have. Well, our mass number, which is equal to protons plus neutrons, is 20. So if we have 20 as our mass number, we know we have 8 protons plus n. We just don't know the number of neutrons. So we can do some math right here, and we get 12 is equal to n. So we have 12 neutrons in this particular oxygen. Let's do one more example with the same thing. Let me erase. Okay, let's do magnesium. So on your exam, you're most likely going to be given a word problem. So let's say determine the number of protons, neutrons, and electrons in a, I'm just abbreviating it, magnesium atom with a mass number of 30. Okay, so you can draw it out or however you want to do it, but I'm going to write it out like we've been practicing. So magnesium, we're given a mass number of 30. I'm going to go ahead and write that up there. We're going to look at the periodic table and see that the number of protons or atomic number is 12. So we can go ahead, let me go back. So let's find out protons, neutrons, and electrons. So we had to find the number, the atomic number, by looking at the periodic table, and we found the number of protons is 12. It's electrically neutral because we don't have a charge right there. So our number of electrons is 12 as well. We just have to find out the number of neutrons, and we do that by taking 30 minus 12 is equal to 18. So our number of neutrons is equal to 18. If we were to take these together, it would equal 30, which is our mass number. Okay, not so bad. So now let's do an example where we're doing the same thing, but we're doing a charged element. So we talked about ionic bonds, and we talked about covalent bonds, and we talked about what they meant. So a covalent bond is sharing. Let me change this. Covalent bond means they're sharing electrons. Ionic bond was a complete transfer. And then we had hydrogen bonds, which are created through partial charges from polar covalent bonds. When we do a complete transfer, so when we're talking about ionic bonds, table salt is your classic example. Table salt is sodium chloride. And if we look at the actual ions themselves, we'll see Na plus and Cl negative, and that would be the ionic bond between these two atoms in table salt. Why do they do this? We reviewed that the valence rule and the octet rule when it comes to electrons, and how the number of electrons in its valence shell determines the kind of bond or reaction it's going to undergo. So when we did our rule, so we'll do a quick review of that. We have an element in the middle, and I'm going to focus on sodium here. Okay, sodium in the middle, and then we have our electron rings. Okay, looking at the periodic table, a normal sodium, let's do orange. Sodium atom has 11 protons, which means it has 11 electrons. 11 protons and 11 electrons. So if you remember the first rule says the first energy shell, which is right here. So first shell can hold 2 electrons. Oh, that's right. So a max of 2 electrons. Every energy cell past that, and there's 7. So second through 7th shell holds 8 electrons max. And this is what you call the octet rule. Okay, so we found sodium. We looked at the periodic table, and we say it has 11 protons. There's no charge on this one, so we have 11 electrons as well. So we're going to fill according to these rules right here. We're going to put 2 electrons in the first energy shell. The next one can hold 8, and we're trying to go until we get to 11. 1, 2, 3, 4, 5, 6, 7, 8. So sodium has 11 total electrons. We put 2 in the first energy shell like we're supposed to, because that's the max that it can hold. And we put 8 in the second energy shell. So we've used 10 electrons of the 11. So we have to go out to the third ring, and it's going to fill 1. So now we have 11 electrons, like sodium is supposed to have. The octet rule says that even though there's the max of 8 electrons, atoms and elements that have 8 electrons are happy. They're stable. So if we look over here at the noble gases, all of these have 8 electrons in their valence shell. And again, the valence shell is the outermost shell. With electrons. So this would be the valence shell. Even if I drew another ring around here, it would not be the valence shell because it's not holding any electrons. So the valence shell is the outermost shell that's actually holding electrons. So in order to be a stable element or atom, you want to have 8 electrons in your valence shell. So this is our valence shell. And if we look at sodium, it only has 1 valence electron. So do you think it's going to be easier for sodium to steal or share 7 electrons, or to get rid of and let go and donate the 1 electron, so that then this shell, if we donated that electron, would be its valence shell, the outermost shell carrying electrons, and it would be full. So that's exactly what sodium does. It completely donates its electron to chlorine, and we get the chloride ion here. So if you look at these charges up here, Na plus is indicating that it has lost a negative charge. It has donated an electron, which means now it has 1 extra positive charge. So we had 11 electrons. If we donate this electron here, and we had 11 protons to begin with, if we donate an electron, now we have 10 electrons. So we have 1 extra positive charge. That's what that means. We have 1 extra positive charge in the form of a proton. It donated the electron to chlorine, so that means that negative charge up there means that it accepted 1 extra electron and now it has one more electron than it does the number of protons that it originally had. Okay, so sodium chloride, we have something with an ion. If it's positive, it's called a cation. If it's negative, we call it an anion. Those are just terms to represent. Cations are electron donors. And anions are electron acceptors. Okay, so now let's do an example where we're trying to do the same thing we did before, but now we're working with a charged ion. Okay, magnesium 2+, and I'm going to do a mass number of 33. Remember, that's the number of protons and the number of neutrons, which are the two subatomic particles that contribute to mass. So let's find the number of protons, the number of neutrons, and the number of electrons. Okay, so looking at magnesium, and we're going to go to the periodic table, that's its atomic number, which is 12. That is going to equal the number of protons. We cannot change that number ever from the number of protons, or else we change the element. If we said it was going to be, we applied this here, and we said it had 13 protons, we'd be aluminum. So magnesium always has 12 protons. That's why it's on the periodic table, and we can go ahead and fill that in. Okay, now let's try to figure out how many neutrons we have, and we take our mass number, and we take away the number of protons, because this is protons plus neutrons, and we find that we have 21 neutrons. Before, we had an electrically neutral element, so we didn't have to figure out the number of electrons. We just said the number of protons was equal to the number of electrons. But now we do. Now we have a charge. And remember, anytime you have a positive charge, it indicates that you donated an electron. Now you have one less electron than you should. In this case, this is indicating that we have 2 less electrons than we should, because it's a 2+ charge. So looking at the original, if it was neutral, we would expect it to have 12 electrons and electrically neutral. However, magnesium, and that's what's indicated here by the 2+, this cation has lost 2 electrons. That's why it has a 2+ charge. So we lost 2 of the original 12, and now we have 10 electrons. So that's how you solve those. We can do another one. We can do let's do chlorine, because that's a negative one. Let's do chlorine with a mass number of 40. And let's find the protons, the neutrons, and the electrons. Okay, let's look at the periodic table to find our number of protons. So we have chlorine is atomic number 17, has to be 17 protons. We'll put 17 here. Let's find the number of neutrons. So we take our mass number, which is the protons plus neutrons, and we take away the protons, which we know now, and we get 23. So 23 is the number of neutrons that we have. Oh, you know what I forgot? I forgot to put the negative charge. That's what it's supposed to be. Okay, so now we have to take a look at the charge right here. And if we look at the number of protons, if it was electrically neutral, we would expect chlorine to have 17 electrons as well. However, we look at this charge and we see a negative charge, which indicates that it has gained an electron. So in this particular anion, we have 18 electrons. should have 17. Now we have a negative charge, which means we gain an electron. So we have a total of 18 electrons. This is the hardest it will get on your exam, trying to determine the protons, neutrons, and electrons in an ion, so an anion or a cation. But you should be able to do this based off of only being given the mass number, which is right here.